We now have a console application that can download our YouTube reporting data, and we have a LeapFrogBI project that can get that data into a database. In this video, we're going to deploy our LeapFrogBI project and complete the load process. Okay, so now that we have all of our components created in our project, we have one less thing that needs to be done before we can actually deploy, and that is we need to fill out the precedence order, which is where we tell LeapFrogBI in what order we want all these components to be executed in, either serial or parallel. Now, I've actually already completed this process, so let's just take a look at the graphic that describes the execution order. From top to bottom here is the top represents the first thing that's going to happen, the bottom is the last task that's going to be completed. And then left to right are tasks that can be executed in parallel, just to orient you a bit to this graphic. So the first thing that's going to happen here in phase 10, group 5, is we're going to run the MFS YouTube component, and that's our multi-file stage component that we've been working on. That's what's going to get all those flat files loaded into our first landing point, which is a volatile stage table. From there, we move to phase 10, group 10, and this is where we're moving all of those stage records that have been loaded into stage tables into PSA tables, or persistent staging area tables. The PSA tables they'll persist all unique versions of records that ever enter the system. So this is our consolidation area. Now, after that's complete, we move on to phase 20, group 10, and this is where we're loading, in this case, just a few dimensions, our video, playlist, channel, and date dimension. Now I'll go over to deploy, select the lifecycle that I want to deploy to, and click Make Current. And that asks LeapFrogBI to queue a build so that I can download and deploy that build. Okay, so while we're waiting on the build to complete, I want to talk about a couple of custom things I needed to do here. The first thing is I wanted to automatically trigger our console application to go out and collect reports before the ETL process runs, so that I can, I'll download all the available reports before the ETL process runs, which kind of keeps everything in sync. Now, to do that, I created an SSIS project, and what I ended up doing was using the task scheduler, the Windows task scheduler, to actually execute my console application while passing in some variables. So let's take a look at that. Okay, so here's my task in the task scheduler. I just called it YouTube task. If I look at the triggers, there's no triggers here. This will never run unless I run it myself directly. Under the actions, though, the details here, you'll see that it's actually running a batch file. And I'll go show you what that batch file looks like. Okay, so here's my batch file. All it does is changes the directory to my current directory, and then it runs 4 different commands using our console application. First, it runs the report list command, and it says, go get all of the reports that are available for all of the jobs that I've created and download them to my F-file YouTube directory. Of course, also creating a record in my control database so I can keep track of what's been downloaded. Then I'm running 3 commands, one for each of the objects lists that I want to get back. I want to get a list of videos, channels, and playlists. So I run a command for each of those, and that populates my control table database object table. So back over to my task here, my Windows Scheduler task, that's really all it does. It just executes that batch file. Now, let me jump back over to SSIS. SSIS is simply executing, or it's starting that Windows Scheduler task. So if I look at the process here, you can see that I'm running a command window, and I'm passing in a command that says, run the scheduled task named YouTube task. That's all it does. Then, so that I know how long to wait for that task to complete, I'm polling for that task's status. So I'm getting the status here. Take a look at that. So here's the command I'm using to get the status of my task, and it's just using it's passing in query, and then it's saying for the task named YouTube task, return a list. And that's just a list. You can look this up. It's just a list of the different properties related to that particular task, one of which is the task status. Then what we do is we evaluate that status. This is just a script here in C#, and it says if the status is running, then don't do anything. If it's something else, then set this, then get out of this loop by setting the task to complete, for example. And then it exits the loop and the package ends. Now, frankly, I went through all this because I was having trouble getting my agent to execute an SSIS package that would in turn execute the console application. So I ended up using the task scheduler to take care of that problem for me. You might be able to use use SSIS to execute your console application directly. That would be a little cleaner, frankly. In any case, I have a package now that I want to run at the beginning of my load process. So we're gonna take care of that after we deploy. But the package is now ready to be integrated into our load process. Okay, so back over to our LeapFrogBI build, which is complete. I received a notification, an email notification saying my build was complete. So I'm back on my deploy lifecycle page here, and I'm going to download the build output, which is this lfbi.zip, and I'm saving it to my deploy location, actually one directory above my deploy location, which for me is over here at C, LeapFrogBI, source, YouTube, build, and I'm going to save it right here. All right, so now that I got the build downloaded, I just simply extract its contents. And I'm extracting it into the exact deploy location that's specified in my precedent settings. Okay, so here's the extracted contents. Now I've already deployed this once, so I'm going to go ahead and redo that deployment just so you can see how this works. So I'm going to go over to Management Studio, and I'm just going to delete this entire database that's called YouTube. Okay, so there's no deployment here at all. Let's go ahead and get our new deployment out. So I'm going to run deployment, just double clicking on the deploy package and executing it. Now what this is doing is just setting up the high level objects like the database, the schemas and such. So that's complete. Now we're ready to begin the load process. So if I go back over to Management Studio now and I refresh my database list, I can see I have a YouTube database here. And inside of it, it's just the overhead objects, the centralized configuration. There's logging, a logging table available now. There's precedent settings and so on. All right, so now we need to, before we actually run the load process, add a record to our precedence table so that the precedent solution knows to go and execute our custom package that we created, which again, that's the package that is going to initiate the data collection from the YouTube reporting API via our console application. And to do that, I need to add an entry to this precedence table. I'm not going to go through all of these fields here. They're pretty self-explanatory, but I do want to say that the one field that's important here is this preserve field. By setting preserve to 1, true, we're saying on our subsequent LeapFrogBI deployments, we don't want LeapFrogBI to overwrite that task. We want LeapFrogBI to leave it in place so that the task is there the next time we actually run the deployment. Okay, so I went ahead and scripted out a little insert statement here. I would use the same script whenever I'm deploying to test in prod. Of course, this only needs to be done once, but I now have a script. I've run it in development. Let's see what the results look like. All right, so here's the custom steps that I added to my precedence table. The only one you really should be concerned with is the first one you see here, task 51, which is going to run that YouTube data collection process, that custom package we just talked about. And I set the order of execution such that this is the very first thing that's going to happen in my ETL process. The second one you see here, which is a finish process, I actually run this system in Azure. And what I want to have happen is after this process is done, I run maintenance steps and I actually shut down the server automatically so I don't keep accumulating costs for the compute hours. Okay, so the other thing I've already done here is I've deployed the LeapFrogBI monitoring solution, which is just an SSRS pre-built project. So if I take a look at what's in here, I have a set of reports available. These are just pre-built reports, and they're pointing to the database I just deployed, which is actually also the LeapFrogBI console. So if I look at this precedence ordered report, it's showing me the status of all of the tasks in my project, and currently I have it set to only show me the tasks that are not complete. So I'm going to go ahead and show everything, and I'll refresh that every 15 seconds. So now, when I begin this execution process, we're going to see that these tasks are going to change from complete to pending execution to assigned to running and eventually complete again. Okay, so typically what happens here is on some schedule, for me it's in the morning, like at 6 a.m., this ETL process will begin automatically based on a schedule that's set on this worker that, again, LeapFrogBI created for me called reset. So this is the job that actually begins the load process. I don't want to wait till 6 a.m. I'm sure you don't either, so I'm going to go ahead and start this job. And that should begin the load process for me, and we're going to just monitor it here for just a few minutes. First, I'm going over to my report. This is my monitoring solution report, and as it refreshes, I can see now that my tasks are all in a pending state. These tasks will become in a running state eventually, and then they'll become complete, and then it'll just work its way down through all of the different tasks. Okay, so I can see right now that my YouTube data collector custom task, the very first one that I wanted to run, it's actually running. So I'm going to go over to my folder here where it should be creating files, and I can actually see here in the lower left corner that it is incrementing. I've had 3,541 files. Just a second ago, I only had 3,540 files. So I know that that's working. Now, the next thing that should happen is the process that begins staging these files should start. And I can see that here. I can see that the files are now being moved out of this folder that I'm looking at, and they're going into this success folder. So there's 32, 34, 38, and so on. Now, as that's happening, the data is being loaded over here in my database. If I refresh my table list, I can see I now have a table called stage channel annotation. And the stage schema name is something that I set up in my connection, completely configurable. But I chose to separate my different objects by schema name. Okay, so I can see, in fact, there is data in here. And if I get a count, 9,900, 10,300. So I know that records are going into this stage table. So this is going to take a while. There's 3,000 something files that are going to have to be processed. So I'll be back in just a minute to show you the results. Okay, so we're just about to the end here of our multi-file stage process. We can see the files now have all disappeared. They're in the success folder. And if I jump back over to my report, which is monitoring the load process, I can see that particular task just turned complete. And we're now moving to the PSA load process, which is moving the data out of those stage tables, and it's merging it into PSA, which of course right now is empty, but as we continue to carry out this load process, PSA will be accumulating all unique versions of records that ever enter the system, which more than likely there's not going to be a lot of changes in these records coming out of the YouTube API, but if there are, we're going to know that that happened and when. Okay, so let's take a look at what we've loaded into our database. First, we have our channel dimension, very small, just one record, not counting the unknown member. Then we have our dimension for date. It's a standard date dimension. We can see that we have a smart key applied for the surrogate. Then we have our playlist dimension, one record per playlist plus the unknown member. And then we have our dimension for each individual video, our video dimension. So that all looks fine. Now everything else we just left in PSA. So we should have 18 PSA tables, which would be all these you see here. Let's take a look at this channel combined just to get our eyes on the data for the first time. Okay, so here's channel combined. Seems pretty reasonable here. We've got our traffic source. We got number of views. Looks good. I'm eager to get this in visualization so I can actually see what the data looks like. It should match up exactly to what we see in YouTube Analytics, but still in all, it'd be great to get our eyes on this data in a visualization, like a chart or something like that. Okay, so that's it. We've got our data now out of those thousands of files and into a database that we can now connect Power BI to and begin to visualize this information. And that's what we're going to do in the next video.